is the older version. This is called Pulse. We are using this since 2009. This has stood us for almost close to 15 years. Now they have another machine called Dio, which has a fiber also. Fiber has few uses, but again it is a recurring cost. The fiber is expensive, and most of the work what you want to do, you can do with this. Now, basically, when we talk about larynx, this black part is called the microscope. You couple the microscope with the laser, and like we were showing, you can make different beams. Unless you have a micromanipulators, you can't have a scanner. You can do lasers like this with a handheld probe if you want to work in the oral cavity. You can have a hand probe. But if you want to work in the larynx, you have to have a delivery through the microscope, attachment to the micromanipulators. Now, this is the console. This is what I should do. Now here you will see two modes. One is a manual, other is a Surgital. Surgital means with the scanner. So if you are not putting on the scanner, work with the manual mode. Just have a handed probe, do whatever you want to do. But here, if you are going to work with the scanner, then you specially use ENT, gynecology, this is general, neurosurgery, so we click on ENT. And then this is the focal length. If you choose larynx, these figures will come 400, 350, 400. This is your working focal length. But if you were choosing say stereotomy, now 250, 275, the same as that of the microscope. And again, one of the other very good uses apart from larynx is stepidotomy. Wow, this can be a very precise finisher. Your days of floaters or some work plate there, you just get the hang of how to make a finisher with this laser. I'll just show you before we go to larynx. Suppose you make like to spot 250, okay? Now, if you get this spot, the size of the spot is 0.8 millimeters. Your piston, what we normally put is 0.6 millimeters. So this is already chosen, it is programmed. And you will get a point there, the circle there. But here, our concern is we want to work in larynx, so we come to larynx. And now here you can do a lot of play around. Now these are the modes how you work. Normally most of the work we work with a super pulse and repeat. Super pulse is delivery of high energy in short time. So it gives very good cutting. The beams are very sharp, you are able to cut issues very fast. Then or you can work in CW mode also. Especially if you want to especially with a continuous beam. Sometimes if you want to work very fast, if you are on the papilloma, you want to work very fast and it need not be very precise, then you can go on to a continuous mode. Here you can control the type, the shape, the different shapes. This is curve to one side, curve to other side, straight and circle for fulguration. This is the size. You can start from 0.5, 1 and go higher and higher, the beam size will be bigger. Here is the depth. So, like we were discussing in the morning, in larynx, don't go very deep. You go work layer by layer. Then this is the timer. You are able to, suppose I go into super pulse repeat mode. Then this is the correct timer where you will get the appropriate energy delivery and good cutting beam. Wattage, normally larynx, the indicator watts are 8 to 10 watts. If you are doing a stepidotomy, it is 21 watts. It is single shot 21 watts. But here you work 10 watts unless you want to do fulguration. Then you come to about 4 or 5 watts, which is just surface fulguration. Suppose you have oral cavity, leukoplakia, erythroplakia, you just want to fulgurate with lower power. The timer is, now you will see once we fire, if I keep it 45, So power will not be there. It is the time between the shots. Here if you keep at 50, it will cut very fast. You will see actually when we the aiming beam. Now see this CO2, the wavelength is 10,542 nanometers. This is beyond the visible spectrum. Visible spectrum is somewhere from 400 to 600 nanometers. This means the naked eye cannot see the CO2 laser beam. So we use an aiming beam. The pink beam you see is either you can use an argon or a helium neon beam. This laser argon is being used. So it is just an aiming beam. The pink color beam is not the CO2 laser beam. And here this is the maximum strength of the beam. But it is always better to keep it at half the strength because once you try to focus the beam in the lens and with the light of the microscope coming in, sometimes you struggle to find the beam. So if you keep it at this aperture, you will find the beam. Secondly, sometimes again when you struggle to, because there is a coaxial axis of the laser microscope patient body. One, it has to be straight. Secondly, you have to focus the microscope and then get laser. So I've seen people struggle for 15-20 minutes to get the beam. Another this thing is hit is you can dim the light. You can dim the light totally and you will see the beam. And then you can increase the microscope. Now here, let me make it ready. So once we make it ready, and you have checked your from there. Are you seeing something?
बैटिंग करने के अलावा दूसरा साइन कर रहा है बीम को देखने
See the beam on the monitor? Yeah, this is in dark. Now we'll put out the light. You tell me what's the difference.
थोड़ी लाइट्स बंद कर दो, ये वाली हॉल की लाइट्स कम कर दो. लाइट्स ये वाली
You should be seeing that. Suppose you have to do a